Okay, now let's look at the question number 5. Okay, we have two reactions here. Okay, C2H6 give C2H4 plus H2, and then the second reaction C2H6 plus H2 give 2CH4. These two reactions take place in a continuous reactor at steady state. The feed contains 85 more percent, okay, 85 more percent ethane. So this is 85 more percent. Okay. And the balance inets. If 85 more percent is C2H6, means inet equals 15 more percent. Okay. The fractional conversion of ethane is 0.501. Okay, fractional conversion. Okay, let's say we put FC. And the fractional yield of ethylene is 0.471. So we use F dot Y, fractional yield. Okay. Calculate the molar composition of the product gas and the selectivity of ethylene to methane production. Okay. So if we assume a 100 mole feed basis, so we will have 100 mole as the feed, and then the composition is 0.85 mole C2H6 per mole and 0.15 mole inert per mole. So this is the first, the first reaction, which is this one. Okay, this one. And then the final state will be N1, which is C2H6. We will have C2H6 left, and C2H4 from this from the first reaction. Then we will have H2 from the first reaction, CH4 from the second reaction, and inert, because this is inert, means we will have 15 more percent inert goes out from the process. Okay, so we can say this is a reactive reaction. That's why we have two reactions here. Okay, so first thing first, to solve this question, what we need to do is we need to use the information given in the question, where previously we know that we have 85 more percent, or it is equivalent to 85 mole, right? Because we assume 100 mole feed basis. Okay, so here will be the initial value is 85 for this one, and then 0 for C2H4, 0 for H2, 0 for C2H6. This is the second reaction, right? Okay, 0, 0, 0. So initially we only have 85 mole of C2H6. Okay, so the intermediate is the extent of reaction, where in this case we have minus epsilon, then we have plus epsilon here, we have plus epsilon. Since this is the first reaction, we add 1 here. Okay, epsilon 1, epsilon 1. Okay, and then the intermediate for the second reaction is we have minus epsilon 2, because this is the second reaction, minus epsilon 2, and plus 2 epsilon 2. So the final one will be 85, which is 85 here, minus with epsilon 1, minus with epsilon 2, because we don't have initial amount for second reaction. Okay, and then for we do for C2H4, for H2, for CH4 here, then what we will get is for C2H6, or the outlet flow rate for C2H6 N1 equals 85 minus epsilon 1, epsilon minus epsilon 2. Here, 85 minus epsilon 1 minus epsilon 2, like we have done here. Okay, And then for C2H4, okay, equals epsilon 1. Okay, this is C2H4, the product for first reaction, but no C2H4 in second reaction. That's why we only have plus epsilon 1 here. And for H2 or N3, we have, okay, look, we have plus epsilon 1 and also minus epsilon 2, because for the second reaction, H2 is the reactant. Okay, then for CH4, we have no CH4 in the first reaction, but we have CH4 in the second reaction, where it is the product for the second reaction. That's why we have plus 2 epsilon 2. Okay, then last but not least, we have for inert N5 equals 15 mole inert. Like I said just now, this is the same feed, the same outlet. Now let's proceed to the next step. We have ethane conversion. If the fractional conversion of ethane is 0.501, the fraction converted and hence leaving the reactor must be 1 minus 0.501. So before we go to this, we go back to the previous lecture where we know that fractional conversion is N reacted over N fed. However, in this case, we don't want to know what is the N reacted. We want to know what is the N unreacted or unconverted. Because of what? Because we want to relate it with N1, because N1 is the outlet. Outlet means the one that is not reacted in the process. So if we change this formula to the unconverted or unreacted term, we will get this formula where fraction unconverted, U is for un, C is for converted, equals N unreacted over N fed. This is N reacted because fraction converted, right? So this one unconverted, it become N unreacted over N fed. So equals N1, N unreacted is N1 because this is the outlet for C2H6. And then for fractional unconverted is 1 minus 0.501. That's why if we rearrange this formula, get this term, this whole term, okay? N1 equals 1 minus 0.501 times this N fed. 1 minus 0.501 times this 85, because the feed for C2H6 is 85. Now we go to the next information given in the question, where we know the ethane yield is 0.471. So if you go to the definition of yield, yield equals moles of desired product form over moles that would have been formed if there were no side reaction and the limiting reactant had reacted completely. Or in other words, we need to know the ratio between C2H4 and C2H6. Okay, so if we have 85 mole C2H6 as feed, and then we know the ratio is 1 to 1, so we can cancel out mole C2H6 here with mole C2H6 here. Okay, then we have 85 times 1 mole C2H4. That's why we have 85 mole C2H4. Then if you go back to this formula, we know that most of desired product form is outlet, right? Outlet for C2H4, which is represented by N2 just now from the flowchart. And then we have moles that will have been formed if there were no start reaction. We assume this is no start reaction happen. So we have this value 85, and then the yield is 0.471. That's why if we rearrange this formula, we will get N2 equals 0.471 times this 85, we get 40. Or 40 is equivalent to epsilon 1. Okay, why do we get epsilon 1 equals 40? So we go back to the previous slide. Okay, here. So you have epsilon 1 equals N2, right? That's why we have N2 equals 40 equals epsilon 1. So if we plug in the value that we have previously, okay, this is equal to 42.4. and this is equal to 40. Okay, so we can put 40 inside this, and then we can obtain the nilai of epsilon 2, where epsilon 2 equals, we bring epsilon 2 to the right hand side, then we have 85 minus 40. 40 is epsilon 1, then we bring 42.4 to the left hand side, okay, equals epsilon 2. So epsilon 2 equals 85 minus 40 is 45. 45 minus 42.4 is 2.6 mole. Okay, so we have 2.6 mole. Next, for N3 and N4 will be very easy because we already have epsilon 1 which is 40, epsilon 2 which is 0.6, so we can do the calculation here. 40 minus 2.6, okay, that's why we have, and 3 equals 33.4 here. Then the same goes to N4. We have 2 epsilon, we have 2 times with epsilon 2, 2.6. That's why we have 5.2 more CH4 here. Then N5, like I said just now, the same with the inlet, which is 15 mole. And then we need to find N total. That's why we have N1, this is N1, the value of N1, this is the value of N2, the value of N3, N4, and N5. The total value will become 140. So to find the composition for each component, as simple as take this value, for example for C2H6, take the value of N1. Okay, I just show you one example. N1 over N total, okay, times with 100%. Okay, we have N1 42.4 over 140 times with 100. That's why we get this value, and you can calculate for others as well. Okay, last but not least, we need to find the selectivity of ethylene to methane production. Okay, so what we need to do is we take the outflow rate of C2H4, okay, or N2 here, okay, N2, over with methane, the outlet flow rate of methane, which is N. That's why we get 7.7 mole C2H4 over mole CH4.